Hello students, today we are going to start module 6, topic 1, capacitors. We will do first lesson today, introduction of capacitors and capacitance. By the end of this lesson, you should be able to know what are capacitors, and you should be able to understand that capacitance is defined as the ratio of charge to voltage and how we can use this capacitor. Basically, capacitor is a passive two-terminal electrical component used to store energy electrostatically in an electric field. The forms of practical capacitors are widely used, but all contains at least two electrical conductors. Here is the formation of a capacitor, how capacitors are made. So you can see there are two metal plates, and both metal plates are connected to the terminals of the battery. The non-conducting dielectric acts to increase the capacitor's charge capacity. So a dielectric medium is in between. This is basically an insulator which do not allow current to pass through it. And it could be a glass or ceramic, plastic film, air or paper. So you can use any material which is an insulator and do not allow current to pass through it. So capacitors are widely used as a parts of electrical circuits in many common electrical devices. Unlike resistor, a capacitor does not dissipate energy. Instead, a capacitor stores energy in the form of an electrostatic field between its plate. So there are two ways to charge capacitor. A bit it's like a rechargeable battery. So how we will see how we use a capacitor to charge it. You can see A and B terminal are the capacitor, two metal plates of the capacitor, and they are connected to the battery. So when the electrons flow from the negative terminal to the plate B, as you know, the conventional current direction is from positive to negative, but actually electron flows from the negative terminal of the battery. So when the electron flows from the negative terminal of the battery, uh, at the same time when the electrons are going to plate B and collected by plate B, at the same time electron flows from the other plate to the terminal of the battery, because there is a repulsion between A and B, because now the negative are coming on the plate B, and all negative charges on plate B will travel towards the positive terminal of the battery due to the attraction, making plate A is positive. There is a little misconception in this point, as we know that when something gains electron, it becomes negative, and when something loses electron, it becomes positive. So gaining a positive charge doesn't mean it is gaining protons or something other things, but gaining positive charge means it is losing electrons. So all the electrons from the plate B is repelled by the electrons on plate B. So all the electrons are moving towards the positive terminal. So the same number of electrons are repelled from the positive plate as are built up on negative plate. So it will be same number of charges. So as many as electrons are collected by B plate, and as many as electrons will be repelled by A plate towards the positive terminal. So electrons can't travel through the dielectric of the capacitor. You know that there is a dielectric medium between plate A and plate B, so no current can flow through it. So a charge builds up on these two plates. So basically, capacitor is used to store a charge, to store energy. So again, in this picture, you can see we say that there is a charge of Q across the plates. We don't say 2Q because of it is having the same charge on both plates, but we will call that Q. Now there's a question, what do you think? What happens if we keep on charging the plates? Does it get easier to charge it, or does it get harder to charge it, or stays the same? So you can pause the video and you can think of what will happen if you will keep on charging the plates. Well done if you come up with the right answer. So you can see the more we charge the capacitor, the harder it gets to keep on charging it, because the charge already on the plates repel the charge we try to add. This is similar, like so on one plate, all the negative charges are going to be added up. So all of these have their repulsion in between of these charges. So all of these charges has the same charges. So it gets harder and harder a little bit. So uh, if you keep on adding charges, it will be a bit slower process to keep charging on it. It becomes a bit more harder. The more charge we add, the higher the potential difference across the plate. So potential difference develops because of the opposite charges from each other, and they cannot flow through the dielectric medium. So that's why the potential difference gets developed. So eventually the capacitor will be fully charged according to the capacity of the plates. So when the voltage between the plate is equal to the voltage across the battery, so it depends on the capacitor size, it depends on the battery side, how much voltage is being provided. So that is the point when the voltage across the capacitor plate and the voltage across the battery becomes equal, then it means that is the point when capacitor is fully charged. So what do you think? Is there a limit to how much charge can be stored in the capacitor? You can pause this video and you can think of your answer. Okay, well done if you come up with the right answer. So yes, there is no limit on charging a capacitor. So capacity can be increased of the capacitor. So when we say we can always use a higher voltage battery as long as the dielectric does not break down, because it depends on the dielectric capacity as well, that how long it will take to stop the current to flow through across the plate. So for a given battery, a small capacitor will store less charge than a larger one. So always you can increase the capacity of the capacitor. It depends on your hand, it depends on your situation. So this is the so water tanks and pumps gives us the little understanding and explanation that a good capacitor will be when it has a water tank with a large base, can store a lot of water with a low water level. You will have less potential difference to raise the water up. You will have to do less work done to raise the level. And in the same sense, this is a poor capacitor, though it is having the same water, it is storing the same charge, but you have to do a lot of work done to charge it. So a water tank with a small base can store the same amount of water, but will have a higher water level and needs more powerful for pump. So again, you can use different scenarios to charge a capacitor in a best way. So a good capacitor stores a large amount of charge for a small voltage. So you have to do less work done across the plates, and what strategy you could use to think of to increase the capacity of a capacitor. Okay, so what is the capacitance? Basically, capacitance is the capability of a capacitor to store energy in it. Mathematically, we will define as the charge it can store per unit of potential difference. So how we will write down this mathematically? The ratio between charge to voltage is equal to the capacitance. And the unit of the capacitance is farad. And 1 farad is the capacitance required to store 1 coulomb of charge when there is a 1 volt of potential difference across the plates. So farad is a quite big unit. So usually we take the SI unit for capacitance is a farad, which is equals to 1 coulomb per volt. But typical capacitance value range from about 1 picofarad. Pico means 10 raised per minus 12, and we take 1 microfarad, which is 10 raised per minus 3, nanofarad, which is 10 raised per minus 9. So these are the symbols like we need to remember. So here is a picture, and there are two questions on the screen. What affects a capacitor's capacitance? So you can pause this video and you can think of your answers. Right, well done. If you come up with the right answer. So first question is, what would happen to capacitance if the area of the plate increases? As you have seen in the previous slide with the water tank example. So if you increase the area of the plates, what will happen? It would have more capacity to store a charge. So capacitance would increase by increasing the area of the plate. Well done if you get the right answer. Second question, what would happen to the capacitance if the separation of the plates decreases? So what do you think? So separation means like, you know that we put the dielectric between the plates. So what do you think? What would happen to the capacitance? Yes, capacitance is greater when there is a narrower space separation between conductors. So you can see it would increase the capacitance. The positive and negative plates are closer together, so the electric field created is larger. You can see because one plate is negatively charged and other plate is positively charged. So positive and negative charge have some strong attraction, electrostatic attraction between that. As I told you in the beginning, what is the basically capacitor? Capacitor is basically which stores energy electrostatically in an electric field. So by charging two plates by different charges, one is negatively charged, one is positively charged, we create electrostatically an electric field. So that's why it is effective to use in. So we can use a more efficient dielectric to increase the capacitance, as I told you. So any insulator can be used as a dielectric. And there are some example of glass, ceramic, plastic film, air, paper, anything you can use which is good for the properties. Right, so there are different ways to construct it. The plates of capacitors are rolled up on one another to make the component more compact for fitting into an electric circuit. And you can see on the right hand side picture, there are different types of capacitor, different shapes, different sizes. Each electrical instrument is full of capacitors. Everything uses the capacitor in our mobile phone, in our electronic devices, in fans. It is widely used in electronics. Right, so this is a quick check on your whiteboard or on your just a rough sketchbook, what you have learned so far. So you can pause this video and then you can answer these 4 questions. Well done. So answers are here. You can mark your answers and move on. Okay, brilliant. So graphically, we can represent capacitance. If we take charge on x-axis and voltage on y-axis, then how we will draw a graph of the capacitor? That would be like the line between them. So by using gradient, we can find out capacitance, because voltage is across x-axis and uh, this is charge on y-axis. So gradient basically y-axis divided by um, x-axis. So basically capacitance is the inverse of the gradient of the graph for a given capacitor. So capacitance is constant, meaning the constant gradient. So therefore the graph we have is a straight line whose gradient is equals to 1 over capacitance. So what do you think? Which line corresponds to the highest capacitance and why? You can pause the video and think of which has the higher capacity and which has the lower. Well done if you get the right answer. So the more steeper it is, it has a lower capacitance. As I told you, the capacitance is the inverse of the gradient of the graph. So usually we say more steeper it is, higher value it has. But in this case, because this is the inverse of the gradient, so more steeper it is, lower capacitance it has, and less steeper it is, it has the higher capacitance. Right, this is your homework. What are the capacitors used for? I want you to research in some electronic devices, how they are used, what are they used for. And there are some uses on the next slide, but I want you to research it a bit more. So they are used in backup power sources, in computers, digital clock. So capacitor microphone is the widely used in electronics word. One plate is free to vibrate, causing capacitance to vary as sound waves hit it. Variation in current are detected and amplified. They are used in displacement sensor. Moving near a charge plate can alter the capacitance of the circuit and hence causes current. I want you to read, to study it independently, because this is something like knowledge based thing. So when you will read through all these uses, and then you will be able to be more confident to understand it. The capacitors are used in soothing circuits, so changes alternating current to direct current using a rectifier. A resistor which allows only current in one direction through with the capacitor across it. So capacitor charges up as the current is supplied and the just discharges when it is not. So capacitors are used in tuning circuits. You can read through all of this and then um, you'll be able to do it. So I'm not explaining this in a detail because I want you to do this as a homework. Yes, there are some questions. I want you to pause the video and practice these questions using the capacitor equation. And as you can see, this is the homework. What are the capacitor used for? And I want you to do this, each question, each use as a 6-mark exam question, and give me as much as detail justifying the 6 marks. Right, if you get the answer for these questions, so answers are here, you can mark it. Okay, well done. If you get them all correct. So what do we know so far? We have seen the capacitance of a capacitor is defined as the ratio between the charge and voltage, and the graph is the gradient of the straight line. Unit is measured in farads. Now we want to know how much energy is stored in the capacitor. So energy is basically that how much energy is being stored. As I told you in the start, that capacitor is a device which is used to store energy electrostatically in the electric field. So that how much energy, so we need to know when the switch is pressed. So the battery does work to move by moving charges from the positive to negative plate. So until there is a potential difference of V volts between them. So this is how the capacitor is being charged. So by definition, the potential difference between any 2 points is equal to the work needed to move 1 coulomb of charge between them. So if by looking into this information, can you work out how much work done battery does? And so how much energy the capacitor is storing? So look at the graph, voltage versus charge. What do you think? You can pause the video and think of your answer. So we will see according to the graph. So if we talk about the work done is equals to Q times V, but if we talk about the this relationship, that potential difference is not constant across the capacitor. So it always, potential difference always varies as the capacitor charges. As I told you in the start, if you keep on charging, uh, then it becomes harder and harder. So what will happen? The potential difference keep changing, keep varies. So we have to take the average of the work done. So that's why when we take the average of it, then we take the average is divided by 2. Initial potential, final potential difference divided by 2. So according to the graph, even the area under the line will give us the same value, half QV, half times charge times voltage. So by using these two equations, like work done is equals to half QV and the other equation Q is equals to CV, we can do a little mathematics to change this equation in terms of capacitance and voltage only and capacitance and charge only. Pause this video and do your little mathematics on your rough work and find out, can you make the new equation in terms of C and V only or in C and Q only. Okay, welcome back and well done if you have done this. So by using these two top equations, you can change these equations in terms of two variables. Right, by using these equations, I want you to calculate the energy stored for the following capacitor. You can pause the video and you can find out your answers. Okay, well done. I hope you have looked through the units carefully, because microfarad, picofarad, you have to change it to the standard international unit farads, and then you will be able to get these answers. You can tally your answers with these answers. Well done if you get correct. If not, you can try again. Here is a little difficult exam question. I will go through with this exam question with you. A student researching capacitance find the following statement in different sources. First statement is, a human body charged to 30,000 volts has only about 0.045 joules of stored electrical energy. So you have potential difference and you have given the energy. Second statement says the human body can be moduled as a capacitor of about 10 picofarad in parallel with the resistor. So determine whether the data given in the first statement are consistent with the capacitance quoted in the second statement. So how we could do that? By using the equations, we can calculate. By using first equation, you can see if I calculate the capacitance, so I get 100 picofarad. While according to the second equation, they said 10 picofarad, so which is not compatible. If I use the second statement, then if I use the capacitance and the energy, then I get energy 0.045. But in the first statement, they have given me energy 0.045 joules. So they are not compatible again. So if we use these two statements and if we calculate different values, so they do not get matched up. So a second part, calculate the static charge on the body referred in the first statement. So again, we will use the equation Q is equals to CV. And by using that equation, you can find out the charge given is 3 times 10 to the power minus 6 coulomb. Second, this question, a spark is seen when a person charged to 30,000 volts brings his hand towards an earth metal plate. Such spark occurs when the electric field strength is sufficient to ionize the air. So the minimum electric field strength of this is 3 times 10 to the power 6 volt per meter, and assume that the hand and the metal plate can be treated as a pair of parallel plates and the voltage between the hands and the earth plate is 30,000 volt. Calculate the greatest separation of hand and plate for which the spark could occur. So remember, we have used the equation in GCSE as well. This one, E is equals to voltage divided by distance. So we know the electric field, we know the potential difference, and by rearranging this equation, we can find out the separation between them. So again, we are using a very simple equation, but the scenario they have given, the capacitor, one plate is earth metal plate and the other plate is the human hand. So they are behaving like a capacitor to store charge. In this question, ions and electrons produced in the electric field between the hand and the plate is this, 3 times 10 to the power 6 volt per meter, and accelerated and may collide with the other particles, causing further ionization. Calculate the force on an electron in this field. So first you have to find out the force altogether, and then you will divide it with the number of charges, and then you will get that. So by using the equation E is equals to F over Q, you rearrange it for force. So you got the force 4.8 10 to the power minus 13. So this is a force on an electron. In this question, they are asking about the number of such particles an electron could ionize. So first we will find out the work done on the all particles 3000, and then we will divide it with 35 because they said the ionization energy of typical particle in the air is 335 electron volt. So by using that we will get that how many number of particles are there. Right, you can pause video at any time and then you do your calculation and understand it. This practice question I have uploaded on Show My Homework, so you can print out from there and practice these questions, and the marking scheme is attached too. Once you complete your question, then you can mark your answers from this video, and you can pause at any time and tally your answers, what you did. So well done if you got right answers, and if you don't get right answer, you can practice again. Again, you can pause this video at any point and then you can mark your answers.